Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all children are welcome to tune in. This lesson is the first in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them on the Tennessee Department of Education website at www.tn.gov/education. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about the things we learned previously. Today we will be learning about linear equations in mathematics. Before we get started, to participate fully in our lesson today, you will need paper and a writing utensil or another note-taking device. Okay, let's begin. In this lesson, we are going to continue working on equations and expressions using the properties of equality to solve linear equations. Keep in mind, there are many ways to solve an equation, and it does not matter which options you choose or in which order. What matters is that you choose the properties of equality to make true statements that lead to a solution in the form of x equal to a constant. Let's start with some vocabulary and concept reminders. To solve an equation means to find all numbers if they exist so that the equation is true. In some cases, simple guesswork can lead us to a solution. For example, consider this following equation. 4x plus 1 equals 13. What number would make this equation true? That is, what value of x would make the left side of this equation equal to the right side? When x equals 3, we get a true statement. The left side is equal to 13, and so is the right side of the equation. In other cases, guessing the correct answer is not so easy. Consider this following equation. Can you guess the number for x that would make this equation true? Guessing is not always an effective strategy for solving equations. In the last example, there are several terms in each of the linear expressions comprising the equation. This makes it more difficult to easily guess a solution. For this reason, we want to use what we know about the properties of equality to transform equations into equations with fewer terms. The ultimate goal of solving an equation is to get it in the form of x, or whatever symbol is being used in the equation, equal to a constant. Here's an example to remind you the properties of equality. Let's try to answer these questions about this equation. Is this equation true? Yes, right now this equation is true. The value on the left side is equal to 5, and the value on the right side is equal to 5. Now let's perform each of the following operations and think about whether or not the equation is still true. Let's start by adding 3 to the left side of the equal sign and adding 2 to the right side of the equal sign. Would this equation be true now? No. The left side of the equal sign would be equal to 8, and the right side of the equal sign would be equal to 7. What if we subtract 6 from both sides of the equal sign? Would it be equal now? Yes, both sides of the equal sign would have a value of -1. What if we multiply both sides of the equal sign by 10? Would this equation be true now? Yes, both sides would have a value of 50. What if we multiply the left side of the equation by 10, but the right side of the equation by 4? Would the equation be true now? No, the left side of the equal sign would be equal to 50, and the right side of the equal sign would be equal to 20. What if we divide both sides of the equation by 2? both sides of the equation would have a value of 5 over 2. But what if we divided the left side of the equation by 2 and the right side of the equation by 5? Would this equation be true? No. The left side of the equation would be equal to 5 halves. The right side of the equation would be equal to 1. What do you notice? Describe what patterns you see. There are 4 properties of equality that allow us to transform an equation into the form we want. If A, B, and C are rational numbers, then we use these properties of equality. If A is equal to B, then A plus C is equal to B plus C. If A is equal to B, then A minus C is equal to B minus C. If A is equal to B, then A times C is equal to B times C. And finally, if A is equal to B, then A divided by C is equal to B divided by C, where C is not equal to 0. All 4 of the properties require us to start with A is equal to B. That is, we have to assume that a given equation has an expression on the left side that is equal to the expression on the right side. Working under that assumption each time we use the properties of equality, we are transforming the equation into another equation that is also true. That is, the left side equals the right side. Let's look at 2 examples. While you're watching, follow along on your own paper or other note-taking device. Remember, if you need a little more time, you can always pause the video to work on the problems, then hit play and we'll go through them together. Let's solve the linear equation. 2x minus 3 is equal to 4x for the number x. Examine the properties of equality by choosing something to add or subtract, multiply or divide on both sides of the equation. Keep in mind there are different potential responses. Let's look at a best choice option for the first step in solving the equation. Remembering that in this and any other equation, the goal is to get x equal to a constant. Therefore, the best choice is the one that gets you to the goal most efficiently. First, we must assume that there is a number x that makes the equation true. Working under that assumption, when we use the property if A is equal to B, then A minus C is equal to B minus C, we get an equation that is also true. So we're going to subtract 2x from both sides. Using another property, if A equals B, then A divided by C is equal to B divided by C, we get an equation that is also true by dividing both sides by 2. If x equals -3/2 satisfies the equation, then when I plug that value into both sides of the equal sign, I will get the same value. So let's try that now. We're first going to start with plugging -3/2 into the left side. Now what I do in this situation is I make this number that I'm multiplying by this fraction also a fraction, so it makes my multiplication easier. Remember, this is just one method. You're welcome to use whichever method works best for you. I'm going to turn 2 into a fraction, 2 over 1, and then I'm going to multiply these two fractions. I'm going to multiply 2 times -3 to get -6, and 1 times 2 to get 2, minus 3. Well, I know that -6 divided by 2 is equal to -3. Minus 3 is equal to -6. So when I plug in that value -3/2 for x on the left side, I get -6. Let's see if I get the same value on the right side. 4 times -3/2. Again, I'm going to use my method of turning 4 into a fraction 4 over 1. And now I'm going to multiply my fractions straight across. 4 times negative 3 would give me negative 12. 1 times 2 would give me 2. And I know that negative 12 halves is equal to negative 6. So since I have a value of negative 6 on both sides of the equal sign, when I plug in the value negative 3 halves for x, I know that the value negative 3 halves satisfies this linear equation. Let's try another example. I'd like you to solve the equation 3/5 x minus 21 is equal to 15. Keep in mind that our goal is to transform the equation so that it is in the form x equal to a constant. If we assume that the equation is true for some number x, which property should we use to help us reach our goal, and how should we solve it? We could use the property if a is equal to b, then a plus c is equal to b plus c, where c is the number 21. And I made the mistake of not putting the variable x in the original equation, so I'm going to put that in now. Now, what if you wanted to subtract 15 from both sides, where c is negative 15? Keep in mind, you want your equation to be in the form of x equal to a constant. Subtracting 15 from both sides of the equal sign puts the x and all of the constants on the same side of the equal sign. There's nothing mathematically incorrect about subtracting 15, but it does not get you any closer to reaching your goal. Which property should we use to reach our goal, and how should we use it? If we use the property if a is equal to b, then a divided by c is equal to b divided by c, where c is 3/5, then we could do the following. Now, I'm going to use my same method of turning this number into a fraction since I'm working with a fraction. This is just one way to solve it. There are plenty of other ways that you could choose as well. So I have 36 divided by 1. I've turned that into a fraction, and I am dividing it by 3/5. Now, when I divide fractions, remember, I change that division sign to a multiplication sign, and I'm multiplying by the reciprocal, which would be 5/3. And now I'm going to multiply my fraction straight across. 36 times 5 is equal to 180. 1 times 3 is equal to 3. And I know that 180 divided by 3 is equal to 60. So now we have to decide, does x equal 60 satisfy the equation? If it does, then I'm going to get the same value on both sides of the equal sign when I plug in 60 for my variable x. Let's try the left side first. So I have 3/5 times 60 minus 21. Again, I'm going to use my method of converting 60 into a fraction since I'm multiplying it by a fraction, so that would turn it into 60 over 1. And then I know I multiply fractions straight across. 3 times 60 is 180. 5 times 1 is 5 minus 21. I know that 180 divided by 5 will simplify to 36 minus 21 is equal to 15. So when I plug in the value 60 for x, the left side of the equal sign is equal to 15. As you can see, the right side of the equal sign is also equal to 15. So that tells me that x equals 60 does satisfy this linear equation. All right, let's try some guided practice. Get your pencil and paper ready, and here's question 1 for you. X plus 2 plus x plus 4 plus x plus 6 is equal to 28. The left side of the equal sign can be transformed by combining like terms. So I can combine all of the terms I see that have an x, and that would give me 4x. And now I'm going to combine all of my constants. So 2 plus 4 is equal to 6, plus 6 is equal to 12. Now, pause the video and work on this question. And when you're done, hit play again and we'll talk through it. We can do that with each of the problems. Which property of equality should we use to get to our answer? If we use the property, if A is equal to B, then A minus C is equal to B minus C, where C is 12. That will get us a step further. So we're going to subtract 12 from both sides. Whoops, made a mistake there. Which property of equality should we use now? If we use the property of equality, if A is equal to B, then A divided by C is equal to B divided by C. If C is equal to 4, then we'll get one step further to solving. And so I have that the value of x is equal to 4. Now we have to see, does 4 satisfy my equation? I'm going to plug it into both sides of the equal sign to see if I get the same value. If I get the same value on both sides, then x equals 4 does satisfy my linear equation. So I'm going to go back to this equation when we combined like terms to simplify. And I'm going to plug in 4 for my variable. Four times 4 is equal to 16. 16 plus 12 is equal to 28. So when I plug in that value 4 for x, the left side of the equal sign is equal to 28. And as you can see, the right side of the equal sign is also equal to 28. So that tells me the value 4 satisfies this linear equation. Let's look at another equation. So we have the equation state the property that justifies your first step and why you chose it. Both sides of the equation can be rewritten using the distributive property. I have to use it on the left side to expand the expression. I have to use it on the right side to collect like terms. Which property of equality should we use now? Great. I'm going to subtract 3x from both sides, and I'm left with 3x plus 4 equals -1. At this point, remember, the end goal is to get a constant, the variable equal to a constant. I see a lot of mistakes with this type of problem with my students. They want to move the -1 over by adding 1. There's nothing wrong mathematically about doing that. However, remember, it doesn't get us any closer to achieving our goal of a variable set equal to a constant. So in this case, we would want to subtract 4. So now we're going to use the property if A is equal to B, then A divided by C is equal to B divided by C if C is equal to 3. And the value of X is equal to -5/3. Now again, I have to see if -5/3 satisfies my equation by plugging it into both sides of the equal sign. We'll start with the left side first. And I'm going to use the simplified version of my equation from when I distributed and I collected like terms. So I'm going to plug in -5/3 for X on the left side. Again, I'm going to use my method of turning this into a fraction. I'm going to multiply straight across because that's how I multiply fractions. So 6 times -5 is going to give me -30. 1 times 3 is going to give me 3. I know that -30 divided by 3 is equal to -10. And -10 plus 4 is equal to -6. So when I plug in the value -5/3 for X, on the left side I get -6. Let's try that same thing on the right side. So I have 3 times -5/3 minus 1. Again, I'm going to use my method of turning 3 into a fraction. And I'm multiplying straight across. So 3 times -5 is -15. 1 times 3 is 3. -15 divided by 3 is -5. And -5 minus 1 is -6. So I see that when I plug in -5/3 for X, I get the same value on both sides. That tells me that X equals -5/3 does satisfy the linear equation. All right, let's look at what we've learned today. We know that properties of equality, when used to transform equations, make equations with fewer terms that are simpler to solve. When solving an equation, we want the answer to be in the form of a symbol X equal to a constant. We've worked a lot of problems today. Here are 2 more that you can try on your own. Our first one says, guess a number for X that would make the equation true. Check your solution. Number 2 says, use the properties of equality to solve the equation 7x minus 4 plus x equals 12. State which property you used in your first step and why you chose it. We will go through these together. If at any point you would like to pause the video and then come back and listen to compare my answers to yours, please feel free to do so. Let's start with number 1. Guess a number X that would make the equation true. Now remember, in this one they're asking us to guess. So what number X would make this equation true? When X is equal to 2, both sides of the equal sign have the same value. 5 times 2 minus 2. 5 times 2 is 10. Minus 2 is equal to 8. And then we see that the right side of the equal sign is also equal to 8. So the value 2, when plugged in for X, would make this equation true. Let's look at number 2. So we're using the properties of equality to see which property we would use in our first step. So 7 minus 4x, let's try that again. 7x minus 4 plus x equals 12. The first thing I want to do is I want to simplify this left side by collecting like terms. I know that 7x and positive x are like terms. That would give me 8x minus 4 equals 12. Which property of equality should we use at this point? If A is equal to B, then A plus C is equal to B plus C when C is positive 4. Let's go ahead and solve this equation. At this point, I would use the property of equality. If A is equal to B, then A divided by C is equal to B divided by C when C is equal to 8. Now on your own, I would like you to plug in this value to both sides of the equal sign to see if you get the same value. If you do, when you plug in 2 for x, then that tells us that 2, when plugged in for this variable, does satisfy our linear equation. You can now complete the student practice worksheet for grade 8, lesson 3, if you would like some additional practice. I enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.